Hello everyone. Today I'll be presenting on a topic that has become absolutely central to how modern science operates: collaboration networks in research communities. By the end of this session, you'll see that collaboration is no longer just an option, it is the engine driving modern scientific progress. Today I'll be talking about a topic that underpins almost every modern scientific advance: collaboration. The title of my talk is Evolving Collaboration Networks in Research Communities. I'll show how and why researchers form networks, how those networks change over time, what makes some collaborations successful and others fail, and where this trend is headed next. We'll look at empirical patterns, real-world examples, and a short case study that illustrates how social network analysis helps us design better science policy and funding strategies. Why does collaboration matter so much? There are three overlapping reasons. First, breakthroughs increasingly require multiple specialties. Take biomedical breakthroughs. They often need molecular biology, computational modeling, and clinical expertise. No single lab holds all of that. Second, efficiency. Collaboration speeds up discovery because groups can split work, reuse shared equipment, and cross-validate results faster than isolated teams. Third, digital enablers. The internet, open data platforms, and scholarly social networks have lowered the cost of working together across distance. Put together, these forces mean scientific problems are now more likely to be tackled by teams than by individuals. That's a big cultural shift from the lone scientist model of the past.
Now that we know why collaboration matters, let's look at the structure of this network today. The collaboration network forms a complex ecosystem. The nodes are researchers, journals, department, institutions, and even countries. The links are co-authorship, grants, shared datasets, or joint supervision. We see many forms: tight interdisciplinary teams, long-running core groups, and sprawling international collaborations. An important concept here is the small world property. It means that most researchers are connected by only a few collaborative steps. Practically, this is why ideas and methods spread fast. A technique developed in one lab can reach another continent through a handful of co-authors. Also, networks are not uniform. Some actors are hub with many connections, while others sit at the peripheral with fewer ties.
Let's examine how these shapes change over time. The longitudinal perspective. The networks are living systems. They form, merge, split, and sometimes fade. I will walk through four patterns we have observed. The first one is dynamic evolution. It means new fields create new collaboration patterns. For example, the rise of data science expand innumerable new cross-disciplinary links. The second one is stable cores. It means beneath the floods, there are stable groups that continue to publish together over years or decades. These cores anchor knowledge and practices. The third one is predictive factors. It means physical proximity, shared facilities, and institutional routines often predict collaborations. If two labs share the core facility, they are more likely to co-author. The fourth one is evolving priorities. It means field change focus over time, merging problems like pandemics or climate impacts, rewire who collaborates with whom. This longitudinal view helps funders and institutions design interventions that strengthen promising collaborations or integrate fragmented communities. The graph shows the international collaboration. Let's look at long-term international trends. Over the past 40 years, both basic science and applied science have become more internationally collaborative. 2 points stand out. First, the fraction of internationally co-authored papers has steadily increased since the 1970s. Second, the difference between international patterns in basic versus applied fields has narrowed. They were converging. This convergence suggests that international ties have matter across the board. Theoretical physicists, chemists, engineers, and clinicians increasingly co-authored across borders. The drivers include easier travel when it is available, shared global challenges, and the online circulation of preprints and the datasets.
Next, we will examine what specifically drives a collaboration to succeed. Successful collaborations aren't accidental. They rest on three pillars: communication, memberships, and environment resources. First, communication. Regular, transparent exchange build trust, reduce duplications of effects, and help resolve conflicts. Second, membership. Diversity in expertise and stable interpersonalities matters. Teams that combine complementary skills and have prior positive interactions produce stronger results. Third, environment and resources. Institutional supports, shared infrastructure, and funding stabilities are scaffolding that lets teams concentrate on science rather than logistics. If one pillar is missing, say poor communication or unstable funding, even the most brilliant teams struggle to deliver. With strong drivers, collaboration improves outcomes. Let's quantify that. The effects of collaborations are measurable. Studies consistently show that collaborative teams publish higher impact papers, in some analysis up to 2 times the citation impact of single author works. Additionally, networks that brings together diverse ideas show a roughly 30% boost in innovation metrics. This can be a patent filings, new methodologies, or breakthrough publications. Importantly, a researcher's embeddedness, how connected they are in a multiple overlapping networks, correlates with their likelihood to generate innovative works. In short, being well connected and working in diverse teams doesn't just produce more papers, it produces more influential and creative science.
In this slide, we are going to see challenges and new frontiers. Before moving into the points, let me explain the word frontiers. Frontiers simply mean new areas, new directions, and emerging possibilities in research collaboration. The first point is network management. We know that research networks are large and complex. In that, people join new teams, leave old teams, or shift between projects. Because of these movements, many connections between researchers become weak. So managing these networks and maintaining smooth communication becomes challenging. The second point is addressing inequalities. This refers to the unfair differences that exist in research communities. Women researchers and researchers from smaller countries often receive fewer collaboration opportunities. So making research networks more equal and inclusive is an important goal. The third thing is leveraging AI. This means using artificial intelligence to understand and improve collaboration. AI can identify patterns, find weak areas in the network, and suggest ways to improve teamwork. This makes collaboration smarter and more efficient. Let us move to the next slide. Before explaining the diagram in it, let me tell you what NSF means. NSF stands for National Science Foundation. It is a major US government organization that funds research and supports scientific development. They study how teams work, how collaboration happens, and how networks grow. This slide has 5 important points in a circular diagram. Let us discuss about it one by one. The first one is SNA typologies. SNA means social network analysis. SNA typologies refers to the different forms of social network analysis. It is basically about understanding the structure and behavior of the collaboration network. It helps us to identify who is central in the network, how researchers are connected, how information flows. Thus, it studies the basic structure and behavior of the collaboration network. The second one is funding insights. This examines how funding influences collaboration. For example, does giving financial support increase cooperation? Does it help teams grow stronger? This section focuses on the impact of funding. The next point is longitudinal tracking. This means tracking the network over a long period of time. It observes how the team changes, who joins, who leaves, whether the collaboration improves or declines. It studies the network year by year. Activity effects. This part looks at the effect of activities such as workshops, meetings, and training programs. It asks whether these activities actually help researchers collaborate better. Innovation output is the final point. It shows the final results of collaboration. It measures whether the team is producing new discoveries, new ideas, research papers, or patents,
It evaluates the overall success of the collaboration network.
Now we are going to see about the topic, the future of research collaboration network. How the future of research collaboration network will be and what are the things we should do to improve the future of research collaboration network. First one is increasing interdisciplinary and global connectivity will accelerate the pace of discovery. More teamwork between different subjects and countries will speed up new discoveries. In the future, scientists from different subjects will work together more than ever. Problems like climate change, new diseases, and clean energy need many kinds of experts. Let us understand this by a practical example, that is COVID-19. During COVID-19, doctors, biologists, computer experts, and math experts from many countries worked together to create vaccines quickly. Because people from different countries and subjects share ideas so that the research becomes faster and better. Next one is data-driven network evolution will guide smarter research policies and investments. It means using data to study research networks will help make smarter decisions. Today, we can collect data on how scientists work together, who they write papers with, which universities join hands, and which teams produce strong results. Let us see with an example. If the data shows that a small university has good researchers but fewer connections, then the government can give them support or link them with bigger university. Another example is if data shows that an area like AI in healthcare is growing fast, more funding can be given there so that money and resources go to the right places. The next one is collaboration will be the main key to scientific progress in the digital age. Today there are many modern digital tools like cloud storage, online labs, shared database, and AI which make teamwork much easier. We all know about GitHub. Computer scientists from different countries work together on GitHub to build new software. Climate researchers share global data online so everyone can study it and utilize it. Because of these digital tools, working together will become the main way to make science move forward. As we come to the end of this session, we can conclude the topic Evolving Research Collaboration Network. The way researchers work together is changing in a big and positive way. Collaboration networks are growing, becoming stronger, wider, and more connected than ever before. Earlier, research mostly happened inside single labs or within one subject. But today, scientists from different fields and different countries are joining together to solve problems that are too big for one person or one team. These networks are evolving because technology makes it easier to connect. With online data, video calls, shared data, and global communication tools, researchers can work together even if they are thousands of kilometers apart. For example, climate scientists, doctors, engineers, and computer experts now work in teams to find new solutions faster. This kind of teamwork would have been very difficult years ago. As these collaboration networks grow, research becomes faster, more creative, and more impactful. When many minds from different backgrounds come together, they bring fresh ideas and new ways of thinking. This leads to better discoveries and stronger results. So, the future of research really depends on how well we build and strengthen these networks. If we continue sharing knowledge, supporting each other, and staying open to new partnerships, we can solve bigger challenges and make meaningful progress. Let us say this in simple words. Research grows when people connect. The more we collaborate, the more we discover. It's time to say thank you. Thank you all for listening so patiently and being such a wonderful audience. I truly appreciate your time and interest. Have a great day ahead.